This is the broadcast for May 3, 2019. Air pollution. Ozone. Ozone is a gas molecule composed of 3 oxygen atoms. If undisturbed, a fine layer of ozone in Earth's upper atmosphere blocks harmful solar UV radiation. At ground level, however, ozone harms people and the environment because it is a reactive molecule. Ozone is considered an important greenhouse gas because it is the air pollutant that can do the most damage to living organisms. Tropospheric ground level ozone is formed indirectly as a result of our modern lifestyle. The culprits are combustion furnaces and internal combustion engines. The most well-known everyday examples are the exhaust gases from cars, ships, and planes. When combustion occurs at high temperatures, the 2 main components of air, namely oxygen and nitrogen, react with each other. The so-called NOx gases are formed. These are the gases nitric oxide, NO, and nitrogen dioxide, NO2. The NOx gases are catalysts. Catalysts speed up chemical reactions. The NOx gases have the unfortunate property that they help carbon monoxide, CO, methane, CH4, and volatile organic compounds, VOCs, to produce ozone. This only occurs during daytime. The explanation for this is that the chemical reaction must also receive a helping hand from solar UV radiation. Strong evidence exists of the deadly impacts of ozone from studies across US, Europe, and Asia. Immediate symptoms include shortness of breath, wheezing and coughing, asthma attacks, and increased risk of respiratory infections. People with reduced intake of certain nutrients, such as vitamins C and E, are likely to succumb to the adverse effects of ozone. Children are also likely to experience harmful effects from ozone because their lungs are still developing and are more likely to be active outdoors when ozone levels are high. Long-term exposure may be linked to permanent lung damage. At sufficient levels, ozone exposure slows plant growth, reduces photosynthesis, and increases a plant's risk of disease. During photosynthesis, plants convert sunlight, carbon dioxide, and water into glucose and oxygen, which is a waste material. Plants receive carbon dioxide and at the same time emit oxygen and water vapor through respiratory pores called stomata. Damage from ozone occurs after ozone enters plants through stomata. Ozone does not get into plant cells themselves, and antioxidants help neutralize ozone molecules. However, damage between cells does take place because ozone reacts easily with other elements. These new chemicals are formed and then can penetrate cells and damage them from within. In 2010, international researchers determined that ozone at ground level reduces wheat production by 7 to 12% and soybeans by 6 to 16%. Researchers from the University of Gothenburg determined in 2004 that ozone pollution reduced potato crops by as much as 20%. And in 2018, Swedish and other European researchers found that ozone at ground level destroys nearly 10% of wheat production in the Northern Hemisphere. While the US and Europe have reduced emissions from combustion and furnaces, presently ozone pollution is increasing in Asia. This is where population growth is greatest and the standard of living is increasing the most. This is happening at the same time as the need for food is increasing. This is an unfortunate combination. More ozone will affect food production, states Anne Valesne of the University of Oslo. A team of scientists studying urban emissions from Manaus, a city of over 2 million in Brazil, discovered that air-polluted plumes from the city lead to elevated levels of ozone and the formation of aerosols above the rainforest. During the project, scientists observed ozone levels 30 to 50% higher than baseline conditions at a location 60 miles downwind of the city. The elevated levels were not present at a site upwind. With the help of computer models, they learned that the levels of nitrogen oxide emitted from Manaus would cause up to 260% increase of ozone and 150% increase in hydroxyl radicals, a potent oxidant. Lead researcher Dandin Wei says these findings suggest that emissions from methane can substantially modify the natural chemistry of the atmosphere over the Amazon rainforest. Regulations targeting ozone and particle pollution have produced a much cleaner environment in California. Once infamous for smog, California has led the U.S. in setting tough standards so far. In 1977, Southern California experienced 121 Stage 1 smog alerts for violating federal ozone standards. The region hasn't had a Stage 1 smog alert since 2003. Cars today are 99% cleaner than 4 decades ago. Still, emission standards and enforcement will become stricter because transportation remains a significant source of climate emission for both California and the country. Many urban areas continue to violate federal ozone standards, and cars and trucks are often cited as the biggest culprits for ozone and particle pollution.